Welcome to Financial Math Derivatives Part 1. This is the first part of two lessons I'm going to have on derivatives. In this lesson, I'm going to talk first about some basic definitions, and then we're going to talk about calls and puts. And then the second lesson will cover some additional ideas like forwards, futures, and swaps. The financial instruments covered in the previous lessons, for example, loans, annuities, bonds, stocks in the last lesson, are all direct claims. You either lend money and receive interest, or you own a share of a company and receive dividends. A derivative is a contract whose value is derived from the performance of something else, an underlying asset such as a single stock, an index of stocks, a bond, a commodity, or an interest rate. And we'll see some examples of these derivatives as we proceed. Derivatives do not represent ownership of the underlying asset. So it's sort of a bet or a gamble as to what may happen with the underlying asset. These are agreements about what will happen if the price of the asset moves in a certain way. Derivatives are widely used for two broad purposes. One is hedging. That means using a derivative to reduce an existing risk. I have an example here. A wheat farmer who locks in a price for the harvest, or a company that fixes its borrowing costs for the next 5 years. Then the other purpose is more speculation or gambling, means using a derivative to take on risk in the hope of profit. For example, betting that a stock will rise or fall without actually buying or selling the stock itself. The same instrument can serve either purpose depending on how it's used. In the remainder of this lesson, we're going to talk about the three families of derivatives: options, futures and forwards, and swaps. And then we'll discuss the structured credit products that became prominent in the years leading to the 2008 financial crisis. The mathematics here is fairly accessible. The forward pricing formula is nothing other than the compound interest formula. And option payoffs require only elementary arithmetic. Swap valuation relies on present value ideas and annuity formulas that we talked about in previous lessons. And just a note here, you might think that a derivative is similar to an insurance policy, but they're not classified as the same. Derivatives derive their value from tradable financial metrics, such as a stock price, whereas insurance policies pay out on specific non-financial events, such as an accident or death, and require the buyer to have a direct, legally recognized stake in the insured entity. So that, for example, your house, yourself, your car, you have ownership in that sense. Whereas derivatives, you don't actually own the stock or the bond. You're betting or stipulating on some change to the stock, for example, its price or uh, its dividend. So these are essentially different, and I just wanted to note that here. So let's look at the first type of derivative, an option. It's a contract that gives its holder the right, but not the obligation, to buy or sell an underlying asset at a specified price on or before a specified date. The key terms, and we'll get into the details, but I just want to define the terms here. The underlying asset, so the stock, the index, the commodity or other item the option is written on. Then the strike price or exercise price, we'll call that K, the price at which the holder may buy or sell. The expiration date, the date on or by which the right must be exercised, this option. And then the premium, the price paid up front for the option contract. Okay, so these are the terms, and we'll use these as we describe the details of options on the following slides. There's two different types of options. We're going to look at them here and then we'll do some examples. So we have a call option. A call gives its holder the right to buy the underlying asset at a strike price K. If the asset's market price at expiration, S sub T, exceeds K, the holder profits by buying at K and immediately selling at the higher market price. On the other hand, if the market price at the time of expiration is less than K, then there's no reason to buy the stock because you're going to lose money. In that case, the option expires worthless, and the holder simply loses the premium paid. Then the opposite or the other option is called the put option. A put gives its holder the right to sell the underlying asset at the strike price K. So the conditions are kind of reversed here. If the market price S sub T falls below K at the expiration time, the holder profits by selling at K, which is higher than the current market price, while the asset is only worth S sub T. And if, on the other case, if the market price of the stock is greater than K, then again the option expires worthless, and the owner of the option just loses the premium they paid for that. So mathematically, you can represent the payouts this way here. It's basically in the case of a call, it's the maximum of the stock price at time of expiration minus K or zero. So if this becomes negative, in other words, if K becomes greater than the stock price, then it's just zero, and then of course you lose the premium. Well, in either case, you pay you lose or you pay the premium, and then you have to subtract that from your potential profit. And then the put is just the opposite. And these numbers here are from my book. I mentioned it in the previous lesson, but I'll mention it here again. The book related to all these lessons has been published. It's actually the third edition, and I'll give you the link to where the book is. Both the paperback is on Amazon, and then the electronic copy I'm giving away free, so you can download that, and then if you go to chapter 9 or section 9, you'll see most of this information there. The difference with the videos, of course, is I can verbally give you more background and kind of explain things a little bit more as opposed to the book. Okay, so let's continue with this. Just to reiterate, these numbering that I have here is from my book. This is section 9. This is actually the first example in this lesson. A call option on a stock has a strike price of $50 and expires in 1 year. The option premium is $4. Consider two scenarios. The stock price at expiry is $60, and the other possibility or the other option to consider is the stock price at the time of expiry is $45. So let's look at each one of these in terms of the payoff. So here we're talking about a call, and the price goes up. So we can buy the stock at $50 and sell it immediately at $60. So we make $10 profit off of this call option. And then we paid $4 for the privilege of doing this. So we have to subtract that, and then our profit is $6 per share. So if we bought more shares, then of course we would just multiply by the number of shares. Now, in the case where the stock price drops, then you have a negative number here when you're doing the calculation. So you wouldn't go ahead and buy the stock in that case. You would just eat the premium that you paid. So you would lose $4 in that case. You may wonder how the put in particular works, and there's a couple of options that I'll mention here on this slide. Now, I'm certainly no expert on this, but this is what I found out to be the two different ways of executing a put. So because a put option grants the right to sell an asset, a common point of confusion is how an investor could sell an asset they don't currently own. In financial markets, holding and profiting from a put option without owning the underlying stock is standard practice. It's the whole idea, really. And investors typically capture this profit through one of two methods. So this is the more direct method, but I guess less common. The first method involves exercising the option. The contract does not require the holder to own the stock until the exact moment of exercise. If a stock drops to $45, for example, and the investor holds a put with $50 strike price, they can buy shares, assuming they have more than one option, which is typical. They can buy shares on the open market for $45 and immediately exercise the option to whoever sold them the option to sell them at 50. So this gives you a $5 profit per share less the initial premium. The second method involves selling the contract itself. This is how the vast majority of speculative trades are handled. The option contract functions as a transferable agreement. As the market price of the stock falls below the stock price, the intrinsic value of that agreement increases. So instead of buying the underlying stock to exercise the option, the investor simply sells the valuable contract to another participant on the open market, capturing the profit directly without ever touching the underlying asset. There are different styles of options, and I emphasize the word styles here, even though they have names like European, American, and Bermudan, they don't pertain to a specific geography or area. They're just styles that have gotten these names. So with that in mind, let's talk about these styles. The European option may be exercised only at expiration time, so that's kind of restrictive. An American option, maybe I should say an American style option, may be exercised at any time up to and including the expiration date. So that's much more flexible. Most exchange traded stock options are American style, and most index options are of the European style. So an index option is a derivative based on a market index like the S&P 500, the Dow Jones Industrial, the Nasdaq, some of the markets in Europe, Japan, and the Far East. So American options are at least as valuable as European options, although they pertain to different entities, so they may not be comparable in a lot of cases. But in general, because an American option can perfectly replicate a European option by the holder simply waiting until expiration, but a European option cannot replicate an American option. Therefore, the American style contract must logically be worth greater than or equal to the European style contract. Then there's a third type. It's called the Bermudan style, which sits between the two, it's exercisable on a set of specified dates. So not just at the end date, but not just at any time either. So, it might be something that has a final expiration of a month, but maybe once a week you get a chance to exercise it early. The playful name Bermuda being between America and Europe is a hint that these are all just style names and not locations. So that's something to keep in mind, as I've mentioned a few times already. I'm going to talk about the put-call parity equation, which we'll develop on this slide here. It's actually pretty easy to prove. I'm not going to do it here, but if you download the electronic version of my book, which is free, I'll give you a link to that. There's an exercise at the end of this section, section 9, exercise 2, that asks you to prove the equation, and then on the very next page, I give you the solution. So just to let you know, I'm just going to state it here on this slide. There is a precise relationship between the prices of a European style call and a European style put that have the same underlying asset, strike price, and expiration time, T. This relationship is known as the put-call parity. And the way we develop this is we look at two different portfolios, each assembled today at time zero. In portfolio A, we buy one call option at price C and invest the present value of K in a risk-free account at rate R. So the present value of K would be K divided by 1 plus R to the N, where there are N periods until the time of expiration for the call. And then portfolio B, you buy one put option at price P and one share of the stock at its current price S. And these two values, these two costs, they're the same. That's this what's called the put-call parity equation. And it's true whether or not the S sub t is greater than K or S sub t is less than or equal to K. Since two portfolios with identical future payoffs must cost the same today, otherwise an arbitrage opportunity would exist. So this is the equation, the put-call parity equation. It's just taking C plus K divided by 1 plus R to the N. In other words, the cost of portfolio A, and the claim is that equals the cost of portfolio B, P plus S, and that gives us our formula. And if you're interested in the proof, as I said, just download my book and look at exercise 2 and section 9 and the solution on the next slide. It's a matter of just considering these two cases. So if you know any 4 of these 5 parameters in this equation, you can solve for the other. So in particular, if you know the price of the put and K, R, N, and S, you can determine the price of the call and vice versa. Then I just have a note here that this applies to European style options, as I stated in the beginning. For American options, the relationship becomes an inequality because of the early exercise possibility. Okay, so we'll look at an example in the next slide where we know some of these attributes and we don't know the remaining one. So we have our example here. There's a European call on the stock with price $55, that's the current price, and then the K is 50, so that's the right to buy that at the end of the period, which is just 1 year. And R is 5%, and the call is $8, and we're asked to find the price of the put. So we use our formula, we just rearrange it slightly, taking the everything on one side except for the price of the put. Then we put in all the numbers we were given, and we get 62 cents. So question for the listener, the call was $8 and the put was only 62 cents. So you may want to think about why that's such a big difference, because it just in general you might think that a put and a call are roughly the same price, but as we see here, they're not even close. And I'll explain that actually on the next couple of slides. It's a little bit complicated, but you may want to think about it before you move on to the next slide. So you may want to pause here. There are two reasons for the difference between the price of the put and the call, which I've calculated up here. We already knew that from the previous slide. It's $7.38. The first reason it has to do with the stock price being 55 and the strike being 50. So the call, as we know, is the right to buy at 50 when the price of the stock was already 55. So there's sort of $5 of intrinsic value right off the start. On the other hand, the put is kind of the opposite of that. You're buying the right to sell at 50, but the stock is 55 now. So the intrinsic value is 0. However, that doesn't mean the put is worthless, because it still has a chance the value could fall below 50. But again, that's less probable than the call. So that explains $5 in this out of this $7.38, and that's the majority of the gap. But there's another piece to it which I'll explain on the next slide. The other aspect is the interest carry. That explains the other $2.38. The call holder gets to delay paying $50 until expiration, so they keep earning interest on that cash in the meantime. That deferral is worth K minus the present value of K, and that comes to exactly $2.38. The put holder, on the other hand, is the mirror of that position. They're waiting to receive the $50 in the future instead of today. So the present value of that future $50 is less. The same $2.38 works in the opposite direction for them. So if we add up the $5 from the last slide and the $2.38, we get $7.38. So both forces favor the call and penalize the put, which is why the put collapses to just 62 cents. So one way to see this is that the entire 62 cents is pure time value. The small chance the stock falls below $50 before the year is out. The call's $8, by contrast, is the $5 intrinsic plus $3 time value, where the $3 breaks into the 62 cents of optionality, the same insurance value the put carries embedded in the call. And you can see this if you expand the equation for the call. And plus the $2.38 of interest carry from deferring the $50 strike payment. So the put is cheap precisely because it is betting against the current $5 cushion and swimming against the current interest rate at the same time. What you might want to try, and I'm not going to do it here, but as an exercise, you may want to just try flipping things around and do the same example, but make the the current price of the stock $45, and then just keep the K the same as 50, and then you should see that the price of the call and the put are kind of in reverse from what we've had before.